Good evening friends, this is my third video. In the last class we dealt with a group pile action of clay and a few problems also we solved. So before that we solved this problem. This is not of group piles, it is of individual pile only, but recently asked in the 2019 question paper. First we will solve this one and next we will go for group piles. Now you see here, a 30 centimeter diameter concrete pile is driven into a homogeneous consolidated clay deposit. So these are the data. Diameter of the pile is 30 centimeter. If you convert this into meter, it is 0.30 meter. CU is given, it is 40 kilonewton per meter square. This is addition factor is given 0.7. If the embedded length is 10 meter. Length is 10 meter, estimate the safe load here. Estimate the safe load here. So it is a single pile, so no question of any group here. So it is in the clay. So we know the formula. So QU is given by for the clay, that is CUBNCAP at the base plus alpha into C into AS. This is the formula for clay. So this is the individual pile, single pile. So here this portion is for end bearing and this is for friction. Now CU, that is CU is given as 40, you take 40 as it is clay, and for clay bearing capacity factor NC is taken as 9 and AP means, see here this is a cylindrical pile. This is a cylindrical pile, and bearing pile you are finding. So cross section at the base you have to take, and this is going to be pi by 4 into diameter of the pile is 0.3. So 0.3 square plus alpha is 0.7 here. It is given. C again, same C for both end bearing as well as friction. So into 40, and AS means you have to find the circumferential axial area here, and this is going to be pi into D into L, and L is 10. And if you simplify this one, you are going to get QU is equal to 289.24 kilonewton, and Q safe is equal to QU divided by factor of safety, and this is equal to 289.24 divided by factor of safety is 2.5, and this is going to be 115.7 kilonewtons. Such many problems I solved in the classroom, but just it is from recently question paper, that's why I solved this. Just have a glance on it. Now we shall move for next problem, that is group action. So take note this problem. A pile group consists of 9 friction piles. 9 friction piles of 30 centimeter diameter and 10 meter length, driven in clay. And the properties of clays are CU is equal to 100 kilonewton per meter square, and here gamma is also given 20 kilonewton per meter cube, as shown in figure. As shown in figure. As shown in figure. Determine the safe load. Determine the safe load. Determine the safe load for the group. Determine the safe load for the group. Take alpha is equal to 0.6 and alpha is equal to 0.6 and factor of safety is equal to 3. Again here also the safe load has been asked. Safe load has been asked. So this is a pile of having group. So 9 piles are there in group. So first you have to find the load for block failure or group failure, and then when it fails individually. First of all, you take down this figure. Figure also given. That is 9 piles are there, 3 in a row, like this. And spacing of piles has been given. So spacing of piles from center to center is 0.75 meter. Again from here this is also 0.75 meter. What else? Yeah, this much only it is given. So now we have to first take down the data, whatever data has been given to us. Now 9 piles are there, means n is equal to 9. N is equal to 9. Diameter is 30 centimeter. So if you convert into meter, this is 30 centimeter. It is going to be 0.30 meter. And 10 meter length, L is equal to, length of the pile is 10 meter. And Cu or C is given as 100 kilonewton per meter square. Apart from this, alpha is also given 0.6. And then factor of safety is, so this much data has been given to you and you have to calculate safe load here. As 9 piles are there, they are arranged in group. So what we have to do is, first of all we have to find the allowable load, that is the load failure by in group, and second time we shall find by individual failure, and whichever is less that we are going to take. Whichever is less that we are going to take. So first of all you write block failure or group failure. So the formula, you know that when it is in group, QUG is given by CUB NC AP plus alpha into C into AS. Alpha into C into AS. CUB is given. NC is also we know for clay. Bearing capacity factor is 9. AP we shall find now. Alpha is given, C is given, AS we have to find. So before doing this, here this is a square, group it becomes square, and here B becomes, see, 2 spacings are there. So 0.75, 0.75. So this becomes 2 into 0.75 plus half diameter here. So half diameter here if you add, so you will get end to end this length B. And this is going to be 2 into 0.75 plus 0.3. So B is equal to 1.8 meter. 1.8 meter. Okay. So now AS you can find directly. So now here substituting these values, CUB means it is given and it is given as 100 kilonewton per meter square. And NC is 9 we take, so it is 1.8. So for the group failure, area is taken as this into this, that is 1.8 into 1.8, 1.8 into 1.8 plus, when you come when you consider the frictional part, alpha you have to take here, adhesion factor, and adhesion factor is 0.6 and C is again 100. And AS means here see here, perimeter of this total group you have to consider. Perimeter area of this one you have to take, and this into length you have to take. Means this area along the friction you have to take. So, to perimeter here it becomes as it is square. So 4 times the 1.8 into length of the pipe is 10. Length of the pipe is 10. So QUG is equal to if you do all these calculations, it is 7263 kilonewton. This is equation number 1. This is equation number 1. Okay. So now after finding block failure, that is 7236 kilonewton it is, we shall go for individual failure. That is individual failure. Individual failures. So when it fails individually, so QU is given by CUB, in same, that is NC into AP plus alpha into C into AS. Alpha into C into AS. Or this is equal to CUB. So CUB here is 100 for individual file. NC is 9 as usual. AP is equal to, you see here, you have to take, at the base, individual file is there, a single file, and the base it is given by pi by 4, circular cross section. So pi by 4 d square. So this is pi by 4 into 0.3 square plus alpha you take. Alpha is 0.6 into C. C is again 100, and AS means for single pipe the circumferential area here is pi into D into L. Pi into D into L, and if you simplify this is 628.8 kilonewton. 628.8 kilonewton. But remember, this is for a single pipe, so 9 such pipes are there. So total QU, if you take, it is 9 into 628.8, and this value is going to be 59.2 kilonewton. This is equation number 2. Remember, in group failure it is 7236 kilonewton, and in individual failure it is 5659.2 kilonewton. As it is less, therefore you have to consider this one. And but we want safe load, so Q safe is equal to this 5659.2 QU divided by factor of safety, that is 3, and this is going to be 1886.47 kilonewton. 47 kilonewton. Follow? Now, next problem we should solve. That is n-pile group or n-pile group has to be proportioned in a uniform pattern in soft clay with equal spacing of piles in the group. Take n is equal to 25. Take n is equal to 25 and m it is given, but as we are already denoting addition factor by alpha, therefore we take alpha is equal to 0.7. Sometimes it is given as mobilization factor. So mobilization factor and addition factors are same here, one and same. So you remember alpha and small m are same. It is alpha is equal to 0.7. Neglect the end bearing effect. And assume that each pile is circular in section. Each pile is circular in section. Once again, I read the problem. A n-pile group has to be proportioned in a uniform pattern in soft clay with equal spacing of piles in the group. Take n is equal to 25 means number of piles has been given. So when equal spacing is there means you have to arrange like this only. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 25 piles are there, arranged like this. Alpha is given 0.7. Neglect the end bearing effect means the problem has been reduced for you. It has been made easier because the first part we have to neglect. Only frictional part we have to consider. Neglect the end bearing effect and assume that each pile is circular in section. Each pile is circular in section. Okay, so most of the data have not been given to you. So only thing we have to find here is what is spacing. Let the spacing is S. We assume that spacing is S. That is from center to center. So from center to center, the spacing is S. And diameter is also not given. So we shall assume that let D be the diameter of each pile. Spacing is S. Diameter is D, and n is equal to 25 has been given, so we have assumed n is equal to 25 here. So now B becomes here, B in this sense, so this breadth of this group, so 1, 2, 3, 4, how many spacings are there? 4 spacings are there, half diameter here, half diameter here, so B is equal to 4s plus D. B is equal to 4s plus D. And we shall assume that let L be the length of the pile. All these things you have to assume. Let S be the spacing of the piles from center to center, D be the diameter, L be the length, n is equal to 25. Number of piles has been given to you. So when piles are in group, so width B is given by 4 spacings plus 1 diameter. That is 4s plus D. 4s plus D. Now spacing we want. So what it is given that, whether it is given equal spacing in the point, I will just again once again I will read the question. So the thing has been mentioned here. So but when it hasn't mentioned, then you have to take optimum spacing. And what is meant by optimum spacing means optimum spacing is one where the load carrying in group is equal to block failure is equal to, in this short I will tell you, block failure is equal to individual failure. When this condition is satisfied, means group efficiency is equal to 1 or block failure is equal to individual failure, then optimum spacing happens, and that we have to consider. Based on that one only spacing we have to find. Just we define that Ng is equal to QUG, that is block failure or group failure, into number of piles into QU. So in the optimum spacing what we take Ng is equal to 1, when Ng is equal to 1, this is equal to QUG by N into QU. From this you can write QUG is equal to N into QU. So this condition we use for optimum spacing. Using this condition, generally it is mentioned, even if it is not mentioned. So for optimum spacing you always remember group efficiency is 1 and QUG is equal to N into QU. QUG is equal to N into QU. Now, coming back to the problem. So, the only thing what you have to do is, we have to go for block failure, we have to go for individual failure, find the Q in both the cases, equate them and find the S. So, first of all, we shall go for block failure. We shall go for block failure. So the formula we know, QUG is equal to CUB NCAP alpha C into S. This is the formula you know. So first of all we shall go for block failure. So for block failure, C, the value of C is not given, so we will take it as C. CUB is C. NC is 9, we know this. AP means here, you see here, area of this group failure. So it is square one. So it is how much? See, B you have to calculate first, and B is equal to 4S plus D. 4S plus D and into length. So here AP is equal to 4 into 4S plus D into length, and this is going to be 4 C L 4 C L. I'm sorry here. So in the question, clearly it is mentioned that neglect the end bearing resistance, means this portion you have to neglect totally. So you have to consider only this part. So QUG is equal to, so alpha for the group failure, alpha is taken as 1. C is, we don't know, as usual you take C, into AS means here square is there. So perimeter you take, it is 4 times the 4S plus D into L. So QUG is equal to, so please neglect this one, it has been clearly mentioned in the problem, neglect the end bearing effect. So now this becomes 4CL into 4S plus D. This is equation 1. 4CL into 4S plus D. This is equation 1, and this happens when the piles fail in block or group. Now we shall find when they fail by individual, what happens? So now individual failure. Individual failure. So when the individual failure takes place again, so here also remember you have to neglect the end bearing part. So the formula becomes alpha C into S only, and this is equal to alpha is 0.7, C we don't know, AS is equal to, remember here individual piles you have to take, and for individual pile AS is given by circumference is pi into D into L. So this is pi into D into L. Remember total individual failure is how many piles are there? 25 piles are there. So 25 into 0.7 into C into pi into D into L, or this individual failure QU is given by, if you multiply all these things, so this is 55 DLC. 55 DLC. This is the second one, and the pile is failing individual. Once again I remind you here, in the question clearly it has mentioned that neglect the end bearing effect. Therefore, first part of the formula you have to neglect. First part of the formula you have to neglect. You have to consider only the second part. You have to consider only second part. Now for optimum spacing, group failure is equal to individual failure. Group failure is equal to individual failure. Therefore, equating 1 and 2. Equating 1 and 2. So first was, that is equation 1 was 4CL into 4S plus B, and second equation was 55 DLC. So here CL and CL get cancels. 4 into 4 is 16S plus 4D is equal to 55D, or 16S is equal to 51D. Therefore, S is equal to 51 by 16D, or S is equal to 3.19 times the diameter. So for optimum spacing, the spacing should be 3.19 times the diameter. Follow? Now, one more problem we should take now. A group of 9 friction piles. A group of 9 friction piles arranged. A group of 9 friction piles arranged in a square pattern. In a square pattern, is to be proportion in a deposit of medium stiff clay, medium stiff clay. The size of the piles is the size of the piles is 30 centimeter into 30 centimeter and 10 meter long. 10 meter long. Find the optimum spacing of the piles. Optimum spacing of the piles. Find the optimum spacing of the piles. Assume alpha is equal to 0.8 and Cu is equal to 50 kilonewton per meter square. Once again, one thing I want to remind you, in most of the problems, whatever the problems we are solving, so the soil at the base of the pile and surrounding soils are same we are taking. But sometimes he may give you different soils with a different value of C. At that time you have to take the value of C in the first portion is whatever there at the base of the pile, and in the second part whatever there in the surrounding soil. What is the soil, surrounding soil is there, no? That value of C you have to take for the second part. Okay, now here a group of 9 piles are there. One more different thing here is now instead of circular piles, here the square piles are there. Okay, square piles are there. Given the size of the pile is 30 centimeter into 30 centimeter means it is square piles. So 1, 2, 3. So 9 piles are there. Remember here. So you have to be careful while finding the perimeter and areas when circular piles are given or square piles are given. Okay. So now a group of 9 piles means n is equal to 9. A group of 9 piles is there. Size of this means diameter is not given. Size is given 30 centimeter into 30 centimeter. Means 0.3 meter into 0.3 meter is size of the square. Find the optimum spacing. S is equal to how much? Find the optimum spacing. Take alpha is equal to 0.8 and Cu is given. It is 50 kilonewton per meter square. 50 kilonewton per meter square. It hasn't mentioned that end bearing resistance you have to neglect. It hasn't mentioned here, so you have to consider that also. Same principle here is that the only thing is first you have to take block failure, then you have to take individual failure. You equate both of them for optimum spacing. Group efficiency is 1. Therefore you equate both of them, you simplify them and try to get the value of S. So principle is same, but the calculation is a little bit lengthy here. So first of all I will take block failure. First I will take block failure. So when a block failure is there, we know that the formula QUG is equal to CUBNCAP plus alpha into C into AS. This is for end bearing and this is for frictional part. In the previous problem, this portion was told to be neglected, but by mistake I have considered that one, but it is wrong. So when it is said that this end bearing has to be neglected, the end bearing resistance means this portion you have to neglect. But in this problem, it hasn't mentioned like this. Therefore, you have to consider end bearing part as well as frictional part. Now substituting the values, you see here one by one value I will substitute and whatever needed I will take. Now QUG is equal to CUB means C is given to you. It is 50, no problem at all. NC, as it is clay, so NC we are going to consider 9. Then AP, in a group failure, we have to take the cross section area, means this length into this one. Like this you have to take. You see here, center to center spacing, that only we want to find here, that we consider as S. Again, this center to center is S. So size is 0.3 meter, means half here, half here. So length is going to be here 2S plus 0.3. 2S plus 0.3. Again, two spacings plus 0.3. So 50 into 9 into, that is 2S plus 0.3 into 2S plus 0.3. 2S plus 0.3 into 2S plus 0.3, that is AP plus alpha. So alpha is given here, it is 0.8. It is 0.8 and C is equal to 50. C is equal to 50 and AS is equal to how much? That's the question here. AS is equal to how much here? So same thing here. You have to take perimeter of this one. Perimeter of this one is given by 4 into side. So this is 4 into, the space is not there, I will write here, 4 into 2S 0.3 into length of the pile is how much? It is 10. So these are the various values you have to substitute. Once again, if you go through this one, C is 50 and C is 9 for clay, bearing capacity factor we take 9, and AP means in group the square size is there. So one breadth is 2S plus 0.3, 2S plus 0.3 I have taken here. Alpha is 0.8, C is 50 and AS is 4 into 2S plus 0.3 into 10. 2S plus 0.3 into 10. So we shall simplify this one. So QUG is equal to 50 into 9 is 450. 50 into 9 is 450 into 2S plus 0.3 whole square. So 450 into 2S plus 0.3 whole square plus calculations you also check please. 50 into 4 200, 2000, 2000. One more thing, what the mistake I made here is, as it is block failure, so C should be taken as 1 here. C should be taken as 1 here. So now this becomes plus 2000 into 2S plus 0.3. 2S plus 0.3. This is equation 1. This is equation 1. This is equation 1. So this is a block failure. Second is individual failure. Second is individual failure. For individual failure, again the same formula. CUB, NC, AP, alpha C, AS. So here this is equal to CUB is 50, NC is 9, AP is equal to how much? So when the pile is individual, when one single pile, cylindrical pile is there, at the base circular cross section is there, we used to take pi by 4 d square. But it is square, cross section is square, therefore whatever the cross section area of square is there, that you have to consider here, and it is going to be 0.3 into 0.3. Remember, AP here becomes, when square pile comes into existence, so therefore it is 0.3 into 0.3 plus alpha is 0.8. Here you have to consider whenever it is failing individually, you have to consider alpha, and when it is in group, you have to take it as 1. So alpha, and C is 50. C is 50. Now the question is, AS is how much? When circular is there, what we used to take? Simple formula is there, pi dl. Pi d is circumference and L is length. So here, instead of circumference, perimeter you have to consider, perimeter of this one, and one side is of 0.3, therefore this becomes 4 into 0.3 into length is 10. Length is 10. And if you simplify this one, 50 into 9, 450, 450 into 0.3 into 0.3, it is 40.5. Please you also check the calculations, and if you do all these things, it is 480. So total it is 520.5. 520.5, but this is for individual form, therefore for 9 piles, this is 9 into 520.5, and this is going to be 5 into 9 into 520.5 is 4684.5, and this is second one. This is second one. This is second one. So now for optimum spacing, block failure is equal to individual failure, because here group efficiency we take it as 1. So now equate 1 and 2. Equate 1 and 2. Simplify it. Simplification is a little bit lengthy. To simplify it, you will get, so equation 1 was 450 into 2s plus 0.3 whole square plus 2000 into 2s plus 0.3, and this equal to, just you have calculated, second was 4684.5. So you simplify this, go on simplifying. 450 into 2, 450 into, you have to again square it, a plus b whole square, 4s square plus 0.09 plus 2ab means this becomes 1.2s plus 2000 into 2, 4000s plus this is 600, 2000 into 600, this is 4684.5, and if you all simplify this, bringing all on one side, you will get the equation. This is 1800 s square plus 4540 s minus 4044 equal to 0. This is a quadratic equation. So you go for s is equal to minus b plus or minus under root of b square minus 4ac by 2a, or you can do directly by calculator also. You are having calculator. So on simplifying, you will get s is equal to 697. Yeah. Remember, in the GATE exam also, many times one question there will be on pile foundation 100%, and spacing of the piles most of the times it has been asked. So remember this one. This is the first you find the block failure, then you find the individual failure, equate them and find the yes. So we conclude today's this video. So in the next video, so group pile is over now. In the next video, I will go for settlement of piles and then negative skin friction and under-reamed piles. If you do this much, then pile foundation will be over. I will try to complete the entire syllabus in one video in the next class, and after that important topic still left are design of sheet pile walls. So 4 or 5 videos I will make on that one, so that every case in detail, we can do the design of all type of sheet pile walls. When clay is there, when sand is there, when sand clay is there, clay sand is there, like different cases are there, those things we will solve. Okay, thank you.